Hey guys, here we go. Solving equations and the golden rule of math as it relates to equations. So here we go. What's the golden rule that you already know for life? Do unto others what you would have them do to you. The idea here is balance, equality. And we use the same idea or the same concept in mathematics. The golden rule for math is going to be do to the left side of an equation whatever you do to the right-hand side of the equation. And make sure you do the same thing on both sides. So if you have two things which are balanced, which are equal, if you increase both by 5, they'll still be balanced and equal. If you cut each in half, they'll still be balanced and equal. If you do some crazy, insane operation, but you do it equally to both sides and they started off equal, then they're guaranteed to end up equal. And by doing this process, you're taking something complex and hopefully through operation after operation after operation, it's getting simpler and simpler and simpler and simpler, but it stays balanced, which means at the end, whatever you have is just as true as whatever you had at the beginning. And of course, in mathematics, in order to get the quote right answer, you need to make sure that you haven't deviated from the truth of the initial equation when you're getting your final answer. So the concept for solving is to take some complex expression and undo it by working backwards, little bit by little bit, 1 step, 2 steps, 10 steps, to finally reveal whatever that nugget was, whatever that value was, whatever X was supposed to be for that problem. So to start off, I want to do a thought experiment. Try to close your eyes and imagine your friend chooses a number, any number they want. And I say, okay, friend, add 5 to the number and then tell us what you get. And they say, okay, I did it and I got 12. I want you to think, what was their number? They added 5 to it and then they told you, okay, now I got 12. So what was their number? And hopefully you're going to say 7. But the key is not that you got 7. The key is that what did you have to do to get 7? You got to say, okay, well, if they added 5 to it to get to 12, then I got to work backwards. I got to subtract 5 to see where they started at before they did that. So the math expression would be x plus 5 equals 12. They took some unknown number, they added 5 to it, and they wound up with 12. So what we're going to do is undo that operation by working backwards. So we're going to go minus 5, and we get x equals 7. This is the core principle. And I know this maybe looks too easy, like, Morgan, I don't need to pay attention. This is too easy. I can do it in my sleep. But this is the core principle behind almost all of solving equations for years and years and years worth of mathematics. And when it gets really, really hard, if you've built up a super solid foundation and being very methodical in how you approach problems, you can do the 10-step really hard ones like it's nothing. If you try to do them in your head or you try to just like puzzle your way through, as they get harder and harder and you can't keep track of so many numbers in your head, it becomes hopeless. So I really endeavor to encourage you, whether you're struggling with math or whether you're amazing at math, to kind of build this systematic approach to problem solving. Still do them in your head, still be, fun with numbers and enjoy it if that's your style, but also make sure you're comfortable being methodical and precise in this way. So for example, if I have 6 parentheses x plus 2 close parentheses minus 5 equals 25, this theoretically is just as easy as x plus 5 equals 12. It's more steps, but each step is very straightforward. So the first thing we're going to do is say, well, there's my x hidden way down inside. So let's peel back some layers of this onion. I can add 5 to both sides of an equation, and the equation will still be balanced. So if I add 5 to both sides of the equation, these are going to cancel out because -5 and +5 cancels out. Over here, I'm going to have the same stuff that I had before without any change. And over here, I'm going to have a 30. So what I'm saying is I had some value. When I subtracted 5 from it, I got 25. So before I subtracted 5 from it, it must have been a 30. I think that makes sense. I hope that makes sense. Now we can divide both sides by 6 because I had some value and I multiplied it by 6. After doing that, I wound up with 30. So before I did that, before I multiplied it by 6, I just had x plus 2. And that must have been 5 because I multiplied it by 6 and I got 30. 30 divided by 6 is 5. And now we're saying, hey, this is not so bad. -2, -2. I added 2 to something and I got 5. So before I added the 2, it must have been a 3 because 5 minus 2 is 3. The other really cool thing, and one of the reasons I like solving equations so much is because I like to be right and I like to know that I'm right. I don't like to have any ambiguity or uncertainty. You can take this answer and you can plug it all the way back in to the original problem right here. And you can just check and verify, hey, did I get this right? So let's plug in a 3. 3 plus 2 is 5. 5 times 6 is 30. 30 minus 5 is 25. And you can actually see this progression. We got a 5, then we got a 30, then we got a 25. And you can really nicely map out all your steps and see that they make sense, that they work, that they are correct. And you have every confidence in this answer, so that when you turn in that homework or you turn in that quiz, you turn in that test, you're like, oh, I hope I did well. You're like, I know I did well because I checked them and they are correct. So solving equations and the golden rule, this is the main idea behind it. I want to skip ahead to do some more examples because a lot of times if you're unsure about something, seeing a lot of examples is the best way to learn. So let's try some together. 5x equals 20. X plus 8 equals 11. Negative 3x equals 6. And x over 4 equals 12. So these are all one-step equations. They're all meant to be very straightforward and easy, but they help illustrate the idea of do the opposite of whatever has happened to recover what the answer was before you started manipulating it, before you started doing things to it. So something after I multiplied by 5 gave me 20. So let's work backwards and divide by 5. Opposite of multiplying is dividing. And we get x equals 4. Check it. 4 times 5 is 20. Yes. After adding 8, I got 11. So before adding 8, I have to subtract 8 to see what it was, uncover it, reveal the result. And I get a 3. Check it, plug it in. 3 plus 8 is 11. Awesome. Before I multiplied it by negative 3, what was it? Let's find out. Divide both sides by negative 3, cancel, and we get x equals negative 2. Plug it back in and check it. Negative 3 times negative 2 is 6. Yes. And then over here, I divided by 4 and I got 12. So before I divided, it must have been 4 times bigger. So multiply by 4, cancel, cancel. X equals 48. Again, check it by plugging it in over here. X divided by 4, 48 divided by 4 is 12. Confident that we are correct. Escalate, two-step problems. 2x plus 11 equals 51. 3 parentheses x minus 8 equals 32. And 5 plus x over 6 equals 20. Okay, let's see what we can do. So two-step problems, I have to work backwards. Do I divide by 2 first, or do I subtract 11 first? This is a decision everybody has to make. Now, the golden rule says whatever you do to one side, you have to do to the other side. So if you divide by 2, you can't just divide by 2 here. You have to divide everything by 2. Now, if you do this, yes, it is correct, but it's going to give you some decimals or fractions. And if you're like me, you'd rather save those to the end. So subtracting 11 is a easier way to start. It's not wrong to divide by 2 as long as you divide everything by 2, but it's far easier to start this problem with adding and subtracting just to cancel out that 11. Then we get 2x equals 51 minus 11, which is 40. We can divide both sides by 2 to cancel out that 2. We can get x equals 20. Plug it back in and check it, and you will see it is correct. Okay, moving on. Just a comment, if these are going too fast, just pause the video as many times as you need. Pause the video. Here we go. We got a 3 outside of parentheses. Option 1, distribute the 3 in to get started. Option 2, check and say, hey, is this number divisible by 3? And unfortunately, it's not divisible by 3. It's going to give me some fractions. So, you can decide, what would you rather do? Would you rather deal with fractions here and then have to add 8 to it? Or would you rather distribute? So sometimes I like to distribute if I have fractions, just to dodge those fractions. Neither one is right or wrong. It's just your personal preference. So distribute the 3 and you get 3x minus 24 equals 32. Add 24 to both sides. Add 24 to both sides. Cancel these bad boys out and you get 3x equals 32 plus 24 is going to be 56. Now divide by 3, and you get x equals 56 over 3. That does not divide evenly, does it? No, it does not divide evenly. I think 3 goes evenly into 54, but not 56. So we can leave it like that, or depending on the situation, you might want to make it a mixed number. or even a decimal, but for us, we'll leave it like 56 thirds. All right, last problem. We've got a division bar, and this one we're going to take an extra second to talk about. A division bar that's written like this means the entire numerator is being divided by 6. So most common mistake people make on this is they try to go -5 minus 5. You can't do that because this 5 is not a whole number 5. It's a 5 that's being divided by 6. So before we can subtract that 5, in fact, it's nice to kind of think about this whole numerator as a piece in parentheses. You can't really take bits and pieces because the whole thing is divided by 6. But what you can do is you can multiply the whole thing by 6, and those cancel out. And over here, we multiply by 6, and now we have 5 plus x equals 20 times 6 is 120. Shortcut is ignore the 0 and just do 6 times 2 is 12, and then throw the 0 back on. -5 on both sides. Cancel. X equals 115. So I know this was kind of fast examples, but like I said, go back to the previous slide, review that concept of working backwards, pause the video, try them on your own, go back and review them, et cetera, et cetera. And if you're having any more trouble, of course, come to office hours or come see me in class. And I look forward to helping you more. All right, take care, guys. Have a good one.